Hamjambo students, I welcome you to our today's class. This class we are going to start a new topic which is on matrices, or also known as the matrix algebra. First of all, we need to understand what is a matrix. A matrix, it is either a rectangular or square arrangement of numbers. In that case, we are going to find that those squares or rectangles, we are going to have the rows or the columns on which those numbers are arranged. So a matrix is normally defined by the number of rows and the number of columns it has. If it has 2 rows and 3 columns, then it is going to be called a 2 by 3 matrix, or a matrix like this whereby we have got 2 rows. Remember, rows, they normally run horizontal, whereas the columns, they normally run vertical. So we are going to witness something like this. The order of a matrix is normally defined by the number of rows the matrix has versus the number of columns that matrix has. So for that case, you need to count. You need to count the number of rows and the number of columns that particular matrix has for you to be able to determine the order of that particular matrix. So we need first of all to note about that. Then after noting that, then those numbers that are going to be in the or forming the rectangle or the square are actually known as the elements. So we have got the dimension or the order of the matrix, which is normally given by m times n, where m is the number of rows and n is the number of columns of that particular matrix. And then we have got the membership. The membership are the elements that make that particular matrix. And you'll find that the elements or the members are always going to be inside a bracket. Today, I want us to look at the types of matrices. First of all, as I've said, the elements will always be inside the bracket. Will always be inside the bracket. Any matrix that we are going to come across or encounter, the elements, which are what we have inside the bracket, must actually be enclosed in a bracket. The types of a matrix: one, we have the null matrix. A null matrix, it is a matrix whose members are all 0, like what we have here. All of them are 0. Then we have got a matrix we call rectangular. A rectangular matrix, it is a matrix where the number of rows and the number of columns are not the same, or they are not equal. So m is not equal to n. Like what we have here, we have got 2 rows, but we have got 3 columns. This is actually a rectangular matrix. We can have another one that maybe has got 3 rows, but only 2 columns. That is still a rectangular matrix. Then, under the rectangular matrix, we can have a matrix we call a row matrix. It is a matrix that has got only 1 row. A column that has got only 1 row, but the columns are more than 1. It is a row matrix. Like here we have got this, but remember the columns, there are 4 of them. We have got this column, this column, this column, and this column, but the row is only 1. That is a row matrix. Then we have got a matrix we call a column matrix, like what we have here. We have got a matrix that is called a column. It is called a column matrix because it has got only 1 column, but more than 1 rows. So we have got only this 1 column, but the rows, there are 3 for this particular matrix. Then we have got a matrix we call a square matrix. A square matrix, it is a matrix where the number of rows and the number of columns are equal. So you can have maybe a 2 by 2 matrix where the 2 rows and the 2 columns make the matrix. We can have a 3 by 3 matrix, a 4 by 4 matrix, a 5 by 5 matrix, all those are known as the square, as long as the number of rows, which is m, is equal to the number of columns, which is n. Then we have got transpose matrix. A transpose matrix is a matrix that is formed after interchanging the rows into columns. Like for example, if we have this matrix A, if we transpose it, which is A now power T, this first row, A, 1, 2, 3, is going to be the first column, 1, 2, 3, downwards. The second row, 4, 5, 6, is going to be the second column downwards, 4, 5, 6. Again, I want to repeat here, the rows, they normally run horizontal, whereas the columns, they normally run vertical. So the row 1, 2, 3 is now changing to be the column 1, 2, 3. The row 4, 5, 6, it is becoming the column 4, 5, 6. So that process of changing the rows to be the columns and a matrix is what we call the transpose. And the matrix that comes out is called a transpose matrix. Then we have got another type of matrix we call identity matrix, or known as the unity matrix. It is a matrix where the first diagonal, which is actually the diagonal that is running from top left to the bottom right, it is having elements all equal to 1 and the others are 0. So like here we have got 1, 1 and these are 0. We can have this one, this is 3 by 3 because it has 3 rows and 3 columns. We have got only one appearing on this column from the top left to the bottom right. They are all 1, but the others are 0. Such kind of a matrix is known as the identity matrix. And you'll note that when we multiply matrices with an identity matrix, it is like multiplying a number by 1. So this is like multiplying a number by 1. When you multiply a number by 1, you get the same number. The same case to matrix as we are going to see. The next type of a matrix is known as the diagonal. Diagonal matrix, it's a kind of a matrix where it is a square and only the numbers other than 0 are appearing on the main diagonal, but the others are 0. Then we have got the scalar matrix. It is where the main diagonal elements are equal and the others are 0. Then we have got what we call symmetric matrix. Symmetric matrix, it is a square matrix whose elements above the main diagonal are mirror images of the elements in the other diagonal. Like for example, if we have the main diagonal, which is actually this diagonal here, to be our mirror line, you will find that this 5, it is going to be reflected here. This 6 is going to be reflected here, and this 7 is going to be reflected. So it's actually like the main diagonal acts like a mirror line. Therefore, these elements are going to be reflected like that. We have this 5 being reflected there, this 6 being reflected there, this 7 being reflected there. That is what we call a symmetric matrix. Sorry. Then we have got a submatrix. A submatrix, it is a matrix that is arrived by either deleting some rows or some columns. Like for example, if we have this matrix G and we delete this column here with elements 2, 0, 3 and 2, 5, 6, if we delete them, what we get it is 9, 10, 7, 4, 9, 10, 7, 4. So H is a submatrix of G. Is a submatrix of G because after deleting the row and the column, what it remains. So it is like a submatrix of the main matrix. That is what we had to discuss today. We shall come now with the operation of matrix in our next lesson. Thank you very much.